A very good evening, friends. And I do understand that I'm standing between you and dinner. And I know that if I overextend this, I may become dinner myself. So I will be brief. I would like to add my word to the many words of welcome that you must have heard to India. I know that you've been all over the country. You've seen a number of places, including my alma mater, Roorkee. And what Pradeep Monga from UNEP and Leena here had asked me to do was to share with you the picture of energy in India, the future of energy efficiency, the kinds of opportunities that exist, the kinds of interventions that have been done. So what I'd like to do is to make three large, big points. The first point is that in India, as in each country represented in the tables in this room, there is a huge demand for energy. And this demand for energy will continue to grow. At the same time, we are all faced with situations in which the availability of energy is becoming an issue. It's becoming both an issue in terms of physical quantities as well as in terms of price. This presents to all of us a challenge on how do we meet the various demands that are put on us. Added to that is the problem of climate change, which implies that while we meet the energy needs of everybody in our societies, we do it in a manner that is responsible from a climate point of view, so that increase in greenhouse gases is as low as possible while we meet our energy demands. That's the first point. The second point is that this essentially means that we invest hugely in energy efficiency and in renewables. Even the conventional energy that we provide would need to be provided in an efficient manner. We would need to make sure that we use it in an efficient manner so that the total demand that grows at the lowest possible cost-effective level it can. And cost effectiveness is an important issue because I can bring the best technology, the most energy efficient technology in the world, but if you can't afford it, there's no point in giving it to you. So that's the second point. And the third point is that there are a large number of instruments that have shown to be effective. And these range from standards and regulations on the one hand, to market-based instruments which promote the adoption of newer technologies on the other, to enabling newer technologies, newer operating practices, newer business models to come in through facilitating them through institutional strengthening and capacity building. In other words, there is a whole suite of actions. What you will do depends on the situation. So that's the third message. Let me expand on each one of them. Energy demand. There's often the question is asked, well, how much should countries use as far as energy is concerned? What is enough? This is a difficult question to answer. And I have tended to look at it from the point of view that it should be enough that people have a reasonable quality of life. Now, if you look at the Human Development Index, and let us assume that a Human Development Index of at least 0.9 on a 1-point scale is where we would like our countries to be ultimately, then there is no country in the world which has been able to achieve it without providing at least 3 tons of oil equivalent of energy per person per year. So that is what we need. Now, what is also true is that every country that industrializes later uses less energy to reach the target of 0.9. So the USA's and the UK's used about 9 tons of oil equivalent per person per capita. The Japans used about 5, and the Koreas, which are industrializing today, are able to reach 0.9 at about 3. So it's quite possible that tomorrow and day after, when our countries reach that target, we may be able to do it at a lower amount. But how much lower? My own perception is that I doubt if it will be at less than 2 to 2.5 tons of oil equivalent per capita per year. Okay? So where are we? Now look for your own country, what is your per capita consumption? For India, it's about 0.6 tons of oil equivalent per capita per year. So we are looking at least a tripling. But the important issue is that this tripling is for services, not for energy. What do I mean by that? Look around this room. Do you see electricity or coal or gas anywhere? No. But what we do have is light produced by electricity. What we do have is a water cooler there which is run by electricity. What we do have here is either some kind of heating or cooling which is provided by energy. What we need is lighting. What we need is cooling. What we need is mobility to go from one place to another. Those are the services we need. Energy is only a means to providing those services. Once we realize that, then clearly we can get the same amount of services with less energy input. These are compact fluorescent lights. Much more efficient than the bulbs. Probably use 1/5 as much energy to produce the same amount of light. So if you were using normal bulbs, the amount of electricity you would use would be 5 times, but the light would be the same. If it is changed to LEDs tomorrow, it will become even half of this. But the amount of electricity used would be half, the light would be the same. In other words, it is possible to get the same amount of energy service with less energy input. Okay? Let's leave that argument there for a moment and we'll come back to this. The second issue is that as each one of us looks for more energy, where do we get it from? This is becoming a challenge. As we look into the international market for coal, for oil, for gas, we find that all of the oil and gas and coal is already in long-term contracts. There's a relatively small amount which is traded on a short-term basis. And there is very little addition to the reserves. In other words, there's not much more which is coming to the market. If there's more coming to the market, well, there are old mines, there are old reservoirs which are depleting as well. So the demand in the world is increasing, the supply is remaining more or less constant. And you see this in terms of the prices, the increase in prices that we have seen. The oil prices went up to $120 and $30 a barrel a year or two ago. And I have no doubt that in the short-term future, a few years, they will reach that again. And I think a future of $100 barrel is not only probable, it's going to happen relatively soon. We are going to live in a world of high energy prices. Energy prices are high. Demands are increasing. And while technologies exist that you can provide the same amount of light or air conditioning with less energy, well, those are expensive as well. And all of us come from countries where the ability to pay is limited. This is the problem. All of us face this problem. So what can we do about it? The first thing that each one of us can do about it is to ensure that this energy demand growth is as manageable as possible. How do we do it? Well, first of all, because energy costs money, each one of us in our homes, in our offices, in our factories, tends to invest in technology that uses less energy to produce the same amount of good. whether it is light, whether it is a car, whether it is making cement. I mean, it doesn't matter what it is, but every country in the world, with two exceptions, the amount of energy that you need to produce $1 of GDP keeps declining. This is a secular trend. Because of competitive reasons, it's happening across the world. It's happening in your country, it's happening in my country. So the question is, how do we accelerate it? If we accelerate it, then what would it mean? How can we accelerate it? Well, the first thing that each one of us would have to think is, where is it that it can be accelerated? Where is it that it is not happening on its own? When we studied the Indian market, we found that there were 3 places where there were market failures there were occurring. The first, and I, with almost no hesitation, can say this occurs in every country in the world, is when you go to buy appliances, whether it is an air conditioner, a refrigerator, a light bulb, a fan, no matter what. You know, when we look at them, what do we look at? We look at the brand, we look at the color, we look at the price. We don't know anything about how much energy it will consume, how much of my money will go into paying for the energy that will run that air conditioner. In this country, for example, the amount of energy that I pay for over the life of an air conditioner is 10 times the cost of that air conditioner. If I buy a more efficient air conditioner, that money that I pay out will reduce. But most of us didn't even worry about it. This information wasn't provided to us. And therefore, for many years, the energy efficiency of refrigerators, of air conditioners, and so on was just constant. Across the 90s, for example, there was some increase that occurred when the Montreal Protocol came in and technologies were upgraded. There was some change in refrigerators and air conditioners, otherwise it was constant. So that's the first issue. And to address it, there is a very well-known, very well experimented, across different countries, methodology. And that is, first of all, to provide information to people. Energy labeling. I'm trying to see if there is a refrigerator or air conditioner on which I can show what that looks like. But essentially, what we therefore do is, every air conditioner or refrigerator or other appliance that is sold has a label on it. It gives 2 pieces of information. The first is, how much energy does this particular model consume in a year, obviously under standard conditions. And the second is, it has stars. In the Indian system, it has 5 stars. 5 is the most efficient. So that means amongst all the models in the market, this is the most efficient. And the least is 1 star. Now, when you go to buy, you will obviously look at the cost, the brand, the color, but you also have one more information that you can include in your purchasing decision, and that is, how efficient is it. Now, this has been used in many countries for many years. We started using it only about 6 or 7 years ago, but in 5 years, the average efficiency of air conditioners and refrigerators that were sold increased by 25%. An air conditioner or a refrigerator that is sold today, average, is 25% more efficient than one that was sold 5 years ago. So it has an immediate impact. And it is very easy to communicate to people. Because what you tell them is, if you buy a 5-star, it will save you so many rupees every year in electricity costs. And then the person can do the sums in their head. Okay, this costs so much more. It will save me so many rupees. That means in 2 years, I'll recover my investment, and after that, it's all savings. And people respond. And I'm sure that it's a situation in every country. The industry told us, you are wasting your time. The Indian consumer is extremely cost conscious. He will not buy a more efficient device because it costs more. You are wasting your time, you are wasting our time. We were forced politically to start this system on a voluntary basis. Any manufacturer who wants to get a label can get it. But and we introduced it, some people came in, and we did a huge amount of advertising. We built up the label as a brand. And within a year and a half, 50% of the air conditioners and 75% of the refrigerators that were sold were already labeled. despite the fact that less efficient, cheaper refrigerators and air conditioners were also available in the market. What that told us was that the Indian consumer, like any other consumer in the world, is value conscious. And that put to rest this bogey that poorer consumers do not worry about energy efficiency. They do worry about value. So this is the one intervention I'd like to leave you with. If your country does not have a labeling and standards program, do consider it. If your country does not have a manufacturing industry, it's even better, because then all you have to do is to control imports. And you can use the standards and labels that are used in some other country, which would make sense for you. So this was the first area in which the market failure occurred and for which we have used standards and labeling as an instrument. A very different way of using standards is in the power generation area. Now, power generation is done by very few people. There are 100 plants that are at the most added every year, probably nearer 50 rather than 100. So there what we said was that every new power station that is set up has to use what for coal to electricity is called a supercritical technology. Earlier they used to use a subcritical technology, but we said starting with the year 2012, every new power station that is built will have to be supercritical. That immediately meant a 4% increase in efficiency of conversion. Relatively simple to do, relatively simple to monitor. And so every plant that is being built now is a supercritical plant. Incidentally, it has also meant that the cost of electricity has decreased by about 20% compared to the older, less efficient subcritical technology. So again, this was one of the places where you have a win-win. The second area that I would like to focus on is industry. Industry is a large user of energy, and for many industries, energy is often the largest single cost in their total production cost. Now, for industry, energy costs in India are very high. In global terms, they pay 11 cents a kilowatt hour for electricity, $650 per ton for oil, 1.5 cents per 1,000 kilocalories for coal that is delivered to them. So all of these tend to be very high numbers. Again, they have a great incentive. The problem is, and this is a problem again in all developing countries, we are growing economies. So even if I have a less efficient plant, and it's an older plant, I've already recovered all my money. I am now competing only on the basis of my operating costs. So there is no incentive for me. So if I have money in my pocket, I will put up another plant. Or I can invest in making something completely different, making soap, for example. Because in our countries, there is a great demand and a growing demand for products, any kind of products. By itself, there is very little incentive to invest in enhancing the efficiency of existing plant. So when a new plant is put, it is very efficient. So we had this very strange situation in India that no matter which sector you looked at, some of the world's most energy efficient plants were in this country. Cement, steel, fertilizer, refineries, you name it. And at the same time, there were also plants which used 2 times, 3 times as much energy to produce a ton of cement or fertilizer compared to the best. This bandwidth of energy efficiency, the best in the world, and 2 to 3 times, 4 times in the case of pulp and paper, 6 times as much energy as compared to the best. Now this was a particular problem. If everybody was efficient, we wouldn't have had to do anything. To address this bandwidth problem, what we said was that we mandated that all the energy intensive plants, and we targeted 478 plants which together use about 32% of the total energy used in this country. We said, you guys, you have to become more efficient. If today you use 100 units of energy to produce, say, a ton of cement, then in 3 years this has to come down by a certain percentage. If you're already efficient, that percentage is small. If you're less efficient, that percentage is large. So what it does is that those who have invested in energy efficiency, they are rewarded for it. Those who haven't have to do more. And this is mandatory. What we also said was, if you are able to do better than your target, we will give you the excess savings. You were here, you had to come here, but you have come here. So this savings, excess savings, we will give it to you as a certificate, which then you can sell to anybody else who is not able to meet their target. So as far as we are concerned, we get the total savings we want, but we get cost effectiveness. So that was the second intervention that we did. But please note that this intervention is designed because of that particular problem of the large bandwidth of energy efficiency that we had. And I would not recommend it to anybody who does not have a similar bandwidth problem. The last place where I believe that we had a market failure, which I would like to address, is buildings. And this is particularly difficult. Why? You, for example, make a building. It's a very efficient building. So it costs somewhat more, maybe 10% more than another building which is not energy efficient. And then you go to him and say, please buy it. And he says, here is this building, costs 10% less. Why on earth should I buy something which is 10% more? Looks exactly the same. Now you have already invested in it. And you say, please buy it. Okay, not 10%, pay 5% more, and you ultimately sell it. And you end up making no money. Then he rents it to her. And you are happy, you come into that building, and you are even happier when you get your first energy bill. Because it's an efficient building, the bill is very small. So you end up having the costs, and you end up getting the benefits. This problem of split incentives, as it's called, is a problem in the building energy efficiency area across the world. The issue is, how do we correct it? Now, the first thing that we did, therefore, was to introduce an energy conservation building code. And that code says that everybody who makes a new commercial building will have to put in so much of insulation, have glass which is of this kind, have chillers, the air conditioning chillers which are at least so efficient, and so on and on and on. It tells you what to do. It's a code. And people who built buildings using the code found that they could save 50% energy compared to buildings that were built normally. So there's a huge benefit. Again, you would think this would happen. Now, if people learned this, they should do it. But it's amazingly difficult. Ultimately, these have to be incorporated into the municipal building bylaws. That itself is an effort. Then you have to make sure that there are people who are trained in the municipalities who give the completion certificates, the approval certificates for buildings. Well, you have to train them. You have to train the architects so that they can design these buildings. You have to have people who can supply insulation in the country. You have to have people who can supply energy efficient chillers in the country. This has been the most challenging part of the various kinds of things we have tried to do. It's happening. In our country, in a federal system, the government of India cannot issue a building code for everybody. It has to be done by states and municipalities. 5 states have already notified it. There are another 17 which are at various stages of notification. So I'm reasonably sure that it will be done, but it would have taken a long period of time. What I'd like to end with is therefore to tell you that this has been a very interesting journey, but it has also been a successful journey. In the first 5 years of this program, third-party audits show that they ended up saving about 11,000 megawatts of avoided electric capacity and about 12 million tons oil equivalent of fuels every year. Well, 11,000 megawatts over 5 years and 11 million tons of 12 million tons oil equivalent of fuels every year. Well, it's been worth it. Because what it has meant is that the country has benefited, the people who have invested have benefited from lower costs, and of course, the world has benefited because of the lower rate of increase in greenhouse gas emissions. I'd like to end here. Thank you very much.